Excellent. So this is CAC, Dilemma del Dia, and we're looking at the second problem related to these components. This time we put these two electrical components. Here we have the light bulb and the resistor. They are now in parallel with our power source. If you didn't watch the earlier video, I'd encourage you to watch it first before coming to this one. Anyway, these are two in parallel, and that means that the amps through each of these two components are not necessarily the same. They may be, but they may not be. What is the same is that the voltage across this resistor will be the same as the voltage across this light bulb. We know that because these two components are in parallel. The resistor, as we saw earlier, has a constant resistance. If any value we pick here, for example, 3 volts, and 0.3 amps, we end up getting 10 ohms. No matter where we are on this red line, for the resistor here, we are going to get 10 ohms each time. Excellent. For the light bulb, we have a varying resistance. So for example, this curved line, if we were to check here where we had 1 volt, we only had 0.2 amps. So that's going to be 5 ohms. And if we look up here, it does not continue to be 5 ohms. For example, if we look here at 3 volts and 0.4, we'll see that instead we get 7.5 ohms. So the resistance is changing as we go, and if we want to know the resistance at any point, we make sure that we use the values for voltage and current at that point. We've been told that the total current is 0.7 amps in number 3 here, and that means that the 0.7 amps is going to come along and divide. Okay, and some of the amps will go this way and some of the amps will go that way, but the total amps will be 0.7. So we're looking for a particular voltage such that the 2 amps will add up to be 0.7. So if we tried 1 volt, we see that doesn't work because we get a 0.1 amps here, 0.2 amps here, we'd have a total of 0.3 amps. So that one doesn't work. So we can look and hunt and look for it, and it turns out that we do get 0.7 amps if we add 0.4 and 0.3, which works nicely along this axis line. So we know we have 3 volts across our variable power source, 3 volts. We know that because we're getting 0.3 amps on the resistor and 0.4 amps on the light bulb when we are at 3 volts. That gives us the resistance. We already know the resistance of this one is 10, and as I just mentioned, at this particular location right here, the resistance is 7.5 for the bulb. Number 4. Now we're going to change the voltage down to 1 volt. So here we are. And it asks what's the total current. Well, at 1 volt, we see the resistor will have 0.1 and the light bulb will have 0.2. So our total current will be 0.3. The resistance, I think I just looked at these. This resistor is still a 10 ohm resistor. If we take 1 divided by 0.1, we get 10 yet again. If we look up here, we see that the voltage being 1 divided by 0.2 gives us a resistance of 5 ohms on the light bulb for that particular voltage of 1 volt. And that's how you do these. When they're in parallel, the components, we make sure that the voltage is the same for both components and that the two currents will add up to the total current. Hope that helped. That's the problem of the day. Thank you.